Okay, so today we are going to address non-homogeneous equations. And you may recall non-homogeneous equations are ODEs, linear ODEs on this side, with a forcing function equals, let's call it R of t. With a forcing function. We've done homogeneous ones where this was 0. But now we're going to address the non-homogeneous equations. And we are going to begin with non-homogeneous equations with constant coefficients. So the coefficients of the left-hand side, or the homogeneous piece, is 1, 4, and -5. It gets a little more complicated if I have a function of t here. So let's say you have t y double prime plus natural log of t y prime minus 5t squared y equals a forcing term. So all the ones we are addressing today have constant coefficients, and hence the title. So it's not difficult at all. We just have to break the problem into 2 or 3 pieces. The first piece is you're going to pretend the left-hand side is 0. In other words, you are going to solve this homogeneous ODE. It happens to be, of course, it's linear, happens to be second order. And you know how to do this. We used characteristic equations on the last video. So I hope you can make the jump to go from here to the corresponding quadratic equation. You factor out this binomial, and I got r equals 1 or -5. And therefore, the solutions have to be e to the rt, r is 1, so it's e to the t and e to the -5t. And by linearity, you could, the homogeneous piece, I call it y subscript h, is just a linear combination of these two. Okay? And these are independent solutions. You're not gonna, you can't create this out of this or this out of that. So it has to be a linear combination of the two. So that is your first step. It's usually very easy. You just solve the homogeneous equation where you force r of t to be 0. The second step, and this is where it gets a little sticky, what you want to do is find what we call a particular solution, such that if you plug it in here and hit it with -5 and differentiate that particular solution and multiply it by 4 and differentiate it one more time and add them up, you're going to get 1 plus 2t. So guess a function so that if you plug it in here, you get 1 plus 2t. Now, the right-hand side is a linear function. It is a polynomial. So clearly, we're not going to guess an exponential particular solution or a trig particular solution. We are going to guess some sort of a polynomial. Of course, we're going to begin with a linear polynomial, and hence this guess. So yes, it is true that you're guessing, but it is really an educated guess. You have to think of a polynomial that will produce this. You're not going to think of exponential or trig functions, for instance. So, and we're going to try to figure out what a and b are and whether or not it makes sense, because we might get a contradiction, which means the linear form doesn't make sense, okay? So if this is the guess, we're going to call it a particular solution. Y prime is just b and y double prime is 0. So we're going to plug that in here. So y double prime, we're going to plug in this function here. So y double prime is 0 plus 4 times y prime is b, minus 5 yp. And you're going to force that to be 1 plus 2t. And hence the forcing function, a forcing term. So I rearrange my values here. There are some constants in here, and there are some pieces that have t in them. So I separate them. So 4b minus 5a, that has to equal 1. And -5b t has to equal 2t, right? So you get a system of equations. Easy to solve for b. It's -2/5. I plug it in here, and I got -13/25. And therefore, my particular solution has to be a plus bt. And the last step is just to combine the pieces together. And let me write it down actually. So the actual solution to this entire ODE has to be, again, a linear combination. So you have YH plus YP, okay? So my general solution is YH, here it is, plus YP, here it is, and you're done, okay? So I'm going to do 3 examples or 4. This time what I'm going to do, I'm going to pick a difference forcing term. I'm going to deliberately keep this one because I don't want to repeat myself. I'm just going to keep this for the next 1 or 2 examples. So the left-hand side is the same, but this time I picked e to the 3t. So you already know the homogeneous solution, right? Just look back here. So I'm going to guess an exponential function for sure. But this exponential cannot be, let's say, e to the t, because e to the t, when you differentiate e to the t, you will never get e to the 3t. So I'm going to guess a multiple of e to the 3t. Notice that e to the 3t is independent of e to the t and e to the negative 5t. It's not a duplicate, okay? So this is a completely new piece that with that will give me the solution to this entire ODE. Same process, we differentiate twice and we plug that in here, and e to the 3t cancels. You get 16c equals 1, so c is 1/16. So my particular solution is 1/16 e to the 3t. Feel free to plug it in here, and I can guarantee you're going to get e to the 3t. So therefore, my solution is the homogeneous piece plus the particular piece. Here is the homogeneous piece, and here is the particular piece, and you're done. Okay? So of course, if I have initial conditions, this C1 and C2 will be found. We don't have particular initial conditions, so I couldn't find C1 and C2. Otherwise, I'll be able to. Okay. So the third example, once again, I'm going to give you the same left-hand side, but this time I am choosing another exponential function, but I chose e to the t. And I chose e to the t for a good reason. The purpose of this problem is not to do it. I know you know how to plug in the values. The problem is, if I can guess a multiple of e to the t, I am in trouble, because this is not linearly independent of this. In fact, this is that, or actually a multiple of it. Like if this could be 2 and this could be 4, right? So I'm going to address this a little bit later. This is not going to work, even though your common sense tells you need to pick a multiple of e to the t. Instead, we're going to take advantage of what we did last time with the repeated solution, and I inserted an extra t. Go back to the previous video on how my characteristic equation was a perfect square, and we ended up creating a solution, because you only get one solution double. So one solution, let's say, is r equals t squared, and therefore the second solution is going to be t squared times t. Go back to that previous problem. So I'm going to insert t and hope for the best. Okay, there is a method to this madness, so don't think you're just guessing and checking. Okay, there is a method. Once again, I differentiate once, twice. I kept c outside so it doesn't bother me. Product rule, and then the derivative of this is this, and the derivative of this, I had just done it, which is that. Here it is. This piece is exactly this piece, and this is 2e to the t, and put the pieces together and force it to be e to the t. Of course, I got c 6e to the t equals e to the t, and therefore c is 1/6, and therefore my particular solution is 1/6 e to the t times t. Okay, so it seems to work. You can also plug that in here. I actually did. before I started the video just to double check because I was worried I made a mistake here, and it worked. Again, so my solution is the homogeneous piece plus the particular piece. Here is the homogeneous piece, here is the particular piece. I put t here in green to remind you that you should have a t additional. I'm going to do one more example, then I'm going to go back to see what happens if I do this, okay? This time I picked, I got tired of picking the same homogeneous, so I picked something silly for actually a good reason. But this time the forcing function is a trig function. Now, you might be tempted, well, let me not handle this yet. Let's deal with the homogeneous piece. You could do this in two ways. Notice y double prime doesn't exist, so you don't have a quadratic equation for the characteristic piece. You just have a linear, right? So r minus 2 equals 0, so r equals 1, and therefore there is no y2, okay? y2 doesn't exist. So basically the homogeneous piece is just a multiple of e to the t. Now, because this is so silly, you really don't need to use characteristic equations. This is the very first problem we kind of did, you know, when you first taken this course. You could separate the variables here, right? Remember dp dt equals b? Well, that's the same, right? So y prime equals y. You could separate the variables, integrate, and of course you're going to get an exponential function. So that's why I picked this example, just to show you that you could do this in two ways, okay? Now, we know we're going to have to pick a trig function. If you pick just cosine or just sine, you will never get the answer. Because if you pick the cosine, then you end up with sine here. If you pick the sine, then you'll end up with the cosine, but then you're stuck with sine. And you can't convert cosine into sine. Cosine and sine, cosine is not a multiple of sine and vice versa. You might say, well, no, I can. Cosine of t is sine of pi over 2 minus t, so I can convert cosine into sine. Yes, you can. The problem is you changed your angle. So cosine and sine are independent. So what we have to do is guess a combination of both. This is the trick. And this is why I said there is a method to the madness. Even though you're guessing, most likely you're going to have the right guess. And if you don't, you're going to catch yourself, as I will show you later. So basically, this is the particular guess you're going to choose. Once again, I'm using C's here, so I use letters A and B, so I don't get confused. I differentiate the particular solution or the potential particular solution. I don't have to differentiate it twice. I don't have y double prime. I made it a little nice for me. So twice y prime minus twice y equals negative cosine. Okay? Put alike terms, the signs with together and the cosines are together. Notice that this is 0 sine minus 1 cosine. Okay? Let me write it down. This is 0 sine minus 1 cosine. I wrote this just so that I know how to set up my system of equations. So negative 2a minus 2b has to be 0. There is no sign. And 2b minus 2a has to be negative 1. So a and b are opposites from here, right? So I found b, found a, and once I know a, I know b, and this is my particular solution. And I should write this down. So my y is yp plus yh. Sorry, I should have said yh plus yp. And hence my beautiful solution. It looks simple, but the solution is very long, as you can tell, and it's doable, okay? So what I want to do next, and I'm basically done with my examples, I want to show you what happens if you don't guess right, okay? So recall this one. this example 3, the natural thing to do is to guess c e to the t, and I told you it's not going to work because this exists here. Well, let's run with it. Sometimes the best thing to do in mathematics, when you think something doesn't work or shouldn't work, say, what if I try it then? What if? The what if questions are extremely important in mathematics. Don't just give up quickly. Just say, okay, it doesn't work. What if we make it work? What if I force a number and I square it and I get it and I call it -1, called I squared? What if, right? What if a perfect square is negative? What happens? Well, now, in retrospect, without complex numbers, you couldn't do anything. There is no engineering. There is nothing, absolutely nothing. It comes from a very simple idea of what if. Always ask yourself, what if? So what if I guess this? Okay, I'm going to end with that one. And it's here. So the homogeneous piece was this, and I'm going to guess the particular solution to be a multiple of the forcing function. I didn't mean to pick e to the t. I could have picked anything. I could have picked e to the -5t, right? Or 3 times e to the -5t. I just picked e to the t. It turned out to be very silly because the derivative doesn't change at all. That's just a coincidence, okay? Those don't have to look alike. In any case, when I plug them in here, CET plus 4 CET minus 5 CET equals the forcing function, I got a contradiction. So this is how you catch yourself. Because e to the t is always a positive quantity, right? It's always a positive quantity. Sorry, my exponential function looks really bad. It can never be 0. So you hit a contradiction, and therefore you have to think about, is there something else I can guess? Okay. Now, some of you might say, well, okay, I know this is not going to work. I know we talked about t when we did repeated solutions for the characteristic equation. That's not what we are doing in this. Why t? Why not something else? Again, what if? Well, just run with it. So I started running with it. I'm going to guess, what is that function I have to pick times e to the t? I have to have e to the t. There is no question in my mind. The question is, what should I put in the front? Is it 1? Is it t? What should I pick? Well, we know it's going to be a function of t. I just call it f of t, okay? Or actually, keep things simple. Let's just call it some function of t times e to the t. And hopefully, this f of t will give me t, or 1/6t, as we found. 1/6t. I'm going to let you play with this a little bit at the end. So I found y prime, so product rule, yeah? Y double prime, product rule, and product rule. I hope I didn't make mistakes. And then I plug that in here, right? Y double prime, this piece here. Here it is. Plus 4 y prime, here is y prime. Minus 5y, y is this. And I force it to be e to the t. I cleaned up the mess. I got this, e to the t cancels, and I got this function. This is another ODE. You know, you're trying to solve an ODE, and you end up with another ODE that you have to solve, okay? I'm going to let you continue working on this by yourself for fun. Just explore, okay? I'll give you a couple of hints. You should get f of t, or f, equals 1/6t, because we knew it worked. Right? So if you don't get this, you know you're wrong. That's how you catch yourself. Now, how would you handle this one? I'll give you a couple of hints. I'll give you just one hint. The other two you're not familiar with yet. One hint, one thing you can do is pretend this is a completely new problem. You know, somebody just throws this at you. Y double prime plus 6y prime equals 1. So the forcing term is 1. So somebody just gave you this for the first time, somebody just gives you this non-homogeneous equation, and you proceed with this exactly the same way you proceeded with all of these. This one, this one, this one, and this one. It just looks a little nicer. And usually the simpler looking ones are usually the hardest. So that's one way to do it. You deal with the homogeneous piece, then you have to guess, what kind of a function would you guess here? Would you guess a constant? Would you guess a linear? What do you guess? Push with it, and hopefully you'll get 1/6t. So that's one way to do it. Another way to do it is to integrate twice. So you have f double prime or y double prime, right? Plus 6f equals 1, just integrates. Okay, with respect to t. dt, dt, dt. And of course, this gives you f prime, and this gives you f, and this gives you some sort of t plus some constant. And you differentiate you integrate one more time, right? And that's another way you could approach this problem. See where that takes you. There are two other methods, at least on my mind, that will be helpful, but you don't know them yet. One of them is called the integrating factor, which we're going to learn next. So I'll be able to, basically what it says is, if you have, let's say, y prime plus some function of xy equals some other function, I can turn this into u prime v plus uv prime, which is uv prime. And the way you do it, you multiply both sides of the equation by this expression, okay? We have to prove it, and once you multiply this by this, you'll find yourself, it almost looks like a product rule, but it's not. You need something. So this is the piece that you're going to need. And once you have this, then once you integrate this, you get uv, right? So that's another method which we will learn later. It's called the integrating factor method. We can also use what we call Laplace transform. That's a huge topic which we will deal with in this course. So you have 4 methods at your disposal. I would like you to try the first 2 that I mentioned. Don't try the integrating factor. Don't try Laplace transform yet. And see if you can guess 1/6t. So for those of you, and I'll conclude with this, who have a hard time saying, well, it looks like, I don't want to guess. I don't want to guess. This is ridiculous. Is there a method? Of course there is. This is how you do it. It's a function of t times the forcing term. And you want to know what is that function of t. And once you know, then you have, the right guess would have to be 1/6t e to the t. This is f of t, and this is the e to the t that you definitely have to have. And now you remove all sorts of guesses. You know exactly what to do, okay? So I'm going to conclude here. I hope this is helpful. I'll assign a few problems for you to work on, non-homogeneous ones, and thank you again for listening.